Welcome back to MathAlgo Studio, where math meets code. In this series on computational geometry, from beginner to advanced, we are building strong geometric foundations with a clear focus on implementation. In Lecture 2, we move into three-dimensional lines. We'll understand the 3D line equation, represent it using vector form, and most importantly, see how these concepts are implemented in C++. This lecture is designed to bridge the gap between mathematical theory and real-world coding, especially for applications in CAD, simulation, and geometry engines. So, if you want to move beyond formulas and start writing geometry-driven C++ code, this lecture is for you. Let's begin. Now let's understand how a line is represented in three-dimensional space. In 3D space, a line is uniquely defined if we take any two distinct points. Take 2 points on the line. Point A and point B. With coordinates x1, y1, z1. And point B with coordinates x2, y2, z2. When we join these 2 points, we get a line in space. Now find the direction ratios of this line. They are calculated as L is equal to x to minus x1. M is equal to y to minus y1. N is equal to z to minus z1. This direction ratios tell us how the line moves along the x, y, and z directions. Then line equation using point A is x minus x1 divided by L equals to y minus y1 divided by M equal to z minus z1 divided by N. This is 3D line equation using 2 points. Steps to find the 3D equation of line if 2 points given are as follows. The first step is to find the direction ratios of the line. These represent the direction in which the line moves in space. The second step is to choose any one of the 2 points, usually the first point. Using that point and the direction ratios, the equation of the 3D line is written in symmetric form as shown here. Now we see 3D line equation in vector form. Consider a 2 vectors. Vector A and vector B as shown here. Then the 3D line equation in vector form is as follows. Here, R is 3D position vector of any variable point lying on straight line. T is the parameter whose value is used to locate any point on the line uniquely. P is the vector parallel to straight line by subtracting the corresponding position vectors of two given point vectors. Now let's take an example. Vector v1 is 2i plus 3j plus 5k. And vector v2 is 4i plus 6j plus 12k. As we study last slide, 3D equation in vector form is find the vector p using the formula which is equal to vector b minus vector a. Here vector b is v2 and vector a is v1. Vector p becomes 2i plus 3j plus 7k. Finally, equation of line becomes vector r is equal to 2i plus 3j plus 5k. Plus t into 2i plus 3j plus 7k. This is the final answer. Now let's see how we can implement the 3D line equation in C++ using an object-oriented and vector-based approach. We take same example solved in previous slide. First, we define a class called vector3D. This class represents a vector or a point in three-dimensional space with coordinates x, y, and z. The constructor initializes these three components. Next, we first overload minus means subtraction operator. The minus operator allows us to subtract two vectors. This is useful because the direction vector of a line is obtained by subtracting 2 points. Similarly do for plus operator. The plus operator lets us add two vectors, which we use when computing a point on the line. The multiplication operator performs scalar multiplication, which is required for parametric equations where the direction vector is multiplied by a parameter. So this vector 3D class gives us all the basic vector operations we need. Now let's move to the line 3D class. This class represents a 3D line in vector form. It has two private members. P0, which is a point on the line. D, which is the direction vector of the line. The constructor of this class takes two points A and B. We store point A as P0 and compute the direction vector as B minus A. Next, the function point at t returns a point on the line for any value of the parameter t. It simply computes p0 plus t times d. The print function displays the line equation in vector notation using I, j, and k components, making the mathematical meaning very clear. Finally, in the main function, we define 2 points. A with coordinates 2, 3, 5. And B with coordinates 4, 6, 12. We create a line 3D object using these 2 points and print the equation of the line. So this code is a direct C++ implementation of the vector equation of a 3D line, and the same structure can be extended for CAD, simulation, or computational geometry applications. In the next lecture we will see the C++ codes for more geometry algorithms.